This video covers the forecasting supplement that is posted on WebCT as 1.4, and we'll be using the spreadsheet that is posted directly below that, 1.4.1. In this video, we will take a look initially at building a forecast using a regression model using the trend function. And once we have done that, we will then use that trend function along with a seasonal adjustment to produce a seasonally adjusted forecast. Now, the first page in the spreadsheet is trend, and here we demonstrate coming up with a simple linear regression forecast using the trend function. The forecast is already built into the spreadsheet, so we're going to go ahead and delete this. And I'm also going to go to the name manager and get rid of two names that are in the spreadsheet. I'll take a look at how those are used. Now, the first thing I'd like to do is identify two ranges. And I'm going to create these from selection. What I'm doing is assigning a named range period to this particular range in the spreadsheet, and a second named range demand to the demand observation for this particular problem. What this is going to allow us to do is use named ranges in the function so that they're a little bit clearer. And if I highlight the range along with the header information and click on Create from Selection, Excel is going to take a look at this and assume that the top row contains the names that I'm going to use. And now if I highlight the data itself, the demand, notice that I've got demand showing. Now what this is going to allow me to do is, if I come over to cell C4, equal trend, the name of the function, the known y's, the response is demand. So for known y's, demand, that's that named range, and see how when I type demand, Excel highlights the range that I'm using. The known x's, period, and the new x. Now the new x is a single value versus a range. I would like to forecast for period 1. So I'm simply going to point to the first period. And this gives me a forecast of 36.9. And I can now drag this down all the way down to period 16 and get the actual forecast, the linear regression forecast for each of these periods. Notice that as I copy down, demand and period, as they're named ranges, they act as absolute references. In fact, they are absolute references. The key difference is that the reference is in plain English versus a coded range. Now the second thing that I've got in this spreadsheet, if I'd like to find the slope and intercept, I can use the functions slope and intercept to find the actual values for this model. Beta 0, the intercept, and the known y's, of course, will be demand, known x's, period, and beta 1, the slope. Known y's, once again, demand, and period. So for this particular simple linear regression model, the slope is 1.7. Sales increase 1.7 units per period, starting at 35.2. And if we'd like, we can also plot demand against forecast by inserting a simple line plot. And we can see that the forecast is a perfect linear regression model about the variable demand. Now, moving to the second page, modeling seasonal variation. The first thing we'd like to do is take a look at the seasonal variation for Wishbone Farms, which is a turkey farm out in Floyd, Virginia. Over the past 3 years, 2003, 2004, and 2005, they have recorded quarterly sales. or quarterly demand. For the first quarter 2003, demand was 12.6, second quarter 8.6, and so forth. Notice that the demand is peaking in the fourth quarter. We're going to proceed building this particular forecast in a couple of steps. The first thing we want to do is graph the actual demand to see what type of patterns appear. And when we do this, we see that there is a recurring pattern. Every third quarter we have a low point. Every fourth quarter we have a high point in sales. So this indicates that there is a seasonal variation in the data that we're going to need to accommodate. Now, the way that we will do this is we will figure out what are the annual sales for 2003, 2004, 2005. It does look like there's a bit of an increasing trend in this data, and we'll use the trend function or a linear regression model to model that increasing trend. So the first thing we'd like to do is add up the demand for 2003. Those four demands equal 45. The demand for 2004 is 50, and the demand for 2005, 53.6. So that looking at those numbers, we see that there is a increasing trend year by year. The third thing that we'll do is come up with a seasonal adjustment. We know that the total sales over the 3 years, 148.7. Now, how do we get the seasonal adjustment? Well, it's very simple. If we take the demand for the first quarter, 12.6, 14.1, and 15.3, add those together and divide by the total for all 4 quarters, all 3 years, 148.7, we get 28.2%. So 0.282 of the total sales occur in the first quarter every period. Now, if we take a look at the second quarter, what we're going to do now is add 8.6, 10.3, and 10.6 together, divide by the total 148.7, and that gives us 0.198, 19.8% of the sales in the second quarter. If we do this for the third quarter and the fourth quarter, we'll figure out what the seasonal adjustment is for each quarter, and if we add all of these percentages together, of course we should add up to 1. Now, with the annual demand and the seasonal adjustment, we can now move on to coming up with a forecast. What we'll do for the forecast is take this as the period, the demand, and use the trend function to figure out what is the expected sales for 2006. The total sales for 2006 using the trend function. Once we have the total sales for 2006, we'll break that total sales up according to the seasonal adjustments to figure out what do we expect to see in the first, second, third, and fourth quarter. Now, using the trend function, we figure that based on this trend that we're observing, our 2006 sales ought to be 58.17 birds. And now we can take that 58.17 and multiply it by the seasonal adjustment right here to get our forecast for 2006. Now, of course, if we take the forecasted sales for each of 2003 through 2005 multiplied by those seasonal adjustments, we'll get the forecast for each of the years in our historic data. And of course, this is going to give us the opportunity to compare the forecast with our demand so we can see just how accurately our forecast is matching the actual demand, from which we can infer how well our forecast is going to work in the future. Now, let's go ahead and switch over to Excel. And the second page, the seasonal trend, I am going to get rid of this data right here, the actual forecast, and I'm going to get rid of the trend here. and we'll get rid of the seasonal adjustments. Now, first thing I would like to do is figure out what the actual sales are for each year. And to do that, I'm going to use the SUMIF function. SUMIF is going to take a range and a criteria and a sum range. The range that I'm looking at is column A, 2003 through 2006. Actually, we'll go through 2005, and we'll make that an absolute reference. The criteria I'm looking for, I'd like to sum all of the sales for year 2003. That will be a relative reference. And when I find a match, I want to actually add up what is in the sum column, or the demand column. So from this, I see that I've got 2003 sales 45, 50, 53.6. And now I can use that trend function with the known y's, absolute reference, known x's, absolute reference again, and the new x. So that gives me a forecast sale for 2003 of 45.27, and I can carry that on down through 2006 and find that my forecast sales for 2006 will be 58.17. For the seasonal adjustments, I'm going to do the same thing using the SUMIF function. The range this time will be the quarter. Absolute reference. What I'm looking for is the first quarter, and that's a relative reference, and when I find a match there, again, I want to sum the sales for the particular quarter. And once I've got that total, I'm going to divide that by the sum of sales for the 3 years, and that's going to give me the percentage of sales occurring in each quarter. So we've got 28% first quarter, 19.8% second, 14.7% in the third quarter, 37.2% in the fourth quarter, and if we come down here to the marginal information in Excel, we see that that does in fact sum to 1. Now, to get the forecast, we're going to use another function, the vertical lookup function. And we're going to use that vertical lookup function to find the sales for the year. Vertical lookup, I am looking for 2003 in this particular table where I've got the year and the forecast, and that's an absolute reference. When I find a match to 2003, I want to return the value in the third column. And I'm going to use an exact match here. Now, when I do this, what you see is that I'm actually returning the forecast sales for each year. 45.3, 49.6, 53.9, and 58.17, matching these three values. Of course, what I have to do is I've got to now multiply this by the seasonal adjustment. And I'm going to use a second vertical lookup. The lookup value this time is the quarter. And I'm looking in the adjustment table, absolute reference. When I find a match, I want to return the value that's in the second column of that table. And once again, I want to use an exact match. And with this seasonal adjustment added to this, I now have a seasonally adjusted forecast, and we can see that that seasonally adjusted forecast in gray matches the demand points very closely. So this is the last observation in 2005, and we can see that this forecast is continuing the pattern that we've established in the data.